Welcome to a new edition of the Heather podcast. And today we have a strong woman leading the industry. And actually, this is being recorded on the International Women's Day. And we have Heather Falcone all the way from California. How's it going, Heather?
It's going. Thank you so much, Carlos. I'm so excited to be talking with you for Heat Treat Podcast.
All right, got it. We're going to get a bunch of likes on this one, I'm sure. And I'm super excited to show the world how's the girl power and heat treat, right? We're going to show some muscle today, and we're talking vacuum.
That's right.
Okay, so
best type of heat treating.
Best type of heat treating. Okay, I run atmosphere, but all right, I'll agree with you on this one because you've been so kind to be in the podcast. So Heather, can you tell us a little bit about yourself? What you do? You have an amazing curriculum, but just if you could explain to the audience who you are, what do you do? That'll be fantastic.
Sure. I am the CEO of Thermalvac. We're a family-owned business in Southern California, and we do heat treating, brazing, chemical processing, and specialty coatings. And the business was founded by my father, Steve Driscoll, and he was a welder by trade, and he decided that he could do something a little bit different from his dad, who was also a welder and a metallurgist. So he said one day, hey, let's start a business because I really like working for myself, and I think it's something unique to provide to the customer. So 36 years later, and I'm 38, so that kind of tells you the math on that. Mm-hmm. Here I am as the CEO. I wasn't CEO always, obviously, since I started basically when I was born. But I started out primarily in human resources as an adult. In family businesses, you start working when you're around 12, 10. Mm-hmm. There's pictures of us riding the forklift and doing filing and faxing, and my brother's in a playpen next to me, and that's just our entire life.
You know, you and I have something very similar because I'm also second generation, and just like you, I was born and raised on heat treat.
It's a great life.
It is, and there's people who actually get involved in the business in their 30s or maybe after or maybe on an internship, right, mm-hmm. in their 20s. But it's very different when you are born and raised on heat treat shops.
That's it. You don't even realize that it's your whole life until you start talking about things and people don't understand what you're saying.
so it is. I totally get the feeling. You know, it's rocket science. Actually, it's rocket science this time because I know that you do a lot of you do some work for the space program, which
we do.
We might cover it, and I believe it's a very technical niche heat treating, right? But the people who are here discussing it will love it.
Absolutely. I think that it's not a niche because a lot of people don't know about it. I think it's a niche because the world doesn't understand how much we actually influence their everyday life. So if we could get that word out, I don't think we'd be very niche anymore.
So today's question, right? Because I want to start with this. I read your CV, found it really impressive, and I just gotta say it. How are you a mother, CEO, Ironman triathlete, and 7 Summit enthusiast? How do you manage your time?
The key is to realize that you cannot manage your time. So when I was in my 20s, I had my first child when I was 23. I was a director of the company 5 years after that. Realizing that you cannot be all things to all people was really important as I got more involved in being a mom and being a wife and wanting to have a life outside of work, even though I've been thoroughly invested in work for my whole life. It's really important to emphasize that you're a whole person. So realizing that there are ebbs and flows, natural fluctuations. There's going to be some times that you're really dedicated to work. Sometimes you're going to have to be really dedicated to being a mom. I do have a special needs child with autism and sensory processing disorders. So there's times that you've got to flex. And I think it's the same in business. There are times that you have to flex. You have to be a different leader on every day of the week. You are always on stage. So being adaptable and being able to pivot on a dime, as we've all learned, the favorite word from last year is pivot, right? How are we going to pivot? So learning that early was important because you don't put a lot of pressure on yourself then to be that perfect. I'm a little bit of a perfectionist, so I can't really say I drank my own Kool-Aid all the time, but that's what I try to remember about myself is balance is never going to be a thing and just go with the flow. And that's what really led me to Ironman triathlons because I was looking for a way to lose weight, get outside, do something that was unique and fun and different. And this was back in 2009 before Ironman was a huge explosion and everybody got into it. But, being able to train for something that big was...
I'm actually training right now for Ironman 70.3. Is that how you called it? Half an Ironman.
Half Ironman.
Yeah. It's pretty demanding, it's a lot of hours to put in. But
which race are you going to do?
I'm thinking about doing Monterrey, which is in Mexico, and hopefully it actually gets going, right? We still don't know because of the pandemic. But there's a bunch on Texas, which I believe they're actually going through, right? Everything is, right now, Texas is COVID-free, according to the mayor, right? So let's see how it goes.
Well, congrats. Yeah, that's a big deal.
I don't have really like a time to go to. I just want to finish it,
Absolutely.
Because I suck at cardio, but this is gonna be like my challenge this year. I'll let you know how I go. Actually, that's gonna be 1 week before the MTI meeting, so maybe I'll see you there.
Perfect. Or you can just sign up for Florida because they've got a half and a full too down there.
That'll be fantastic as well. I just have to keep the discipline up. So, but going back a little to heat treat, right? The company you run, it's called Thermalvac, and it's vacuum and bracing oriented. And today we wanted to talk about the vacuum process, their applications. You as well have expressed that you do a lot of work for defense. I know that I'm pretty sure you have a bunch of NDAs, but if hopefully you can share some stuff that is not classified with the audience, because not many, a lot of people are exposed to the automotive work, aerospace, mining, constructions, but very, very, very few have this defense exposure. Or space exploration, which is another very cool industry now with SpaceX and all the Virgin Galactic that is going on. So you could share a little with us. That'll be fantastic. I just don't want to put you on the spot, so feel free to share what you can, right?
Yeah, of course.
And of course, I saw that your company is very capable of NatCap on the quality system. That's also a big thing. And how does the NatCap, if so, gets applied to defense or space exploration? I don't know if there's a way you could share that with us. So let's start with vacuum 101, right? Could you help us understand the vacuum process, their applications, their implications, misconceptions? What do you have to be putting an eye on? I don't know, just you could teach us, enlighten us, because the mission here is to be taught by the very experts, which you are.
I see. Yeah, vacuum experts. That's what we claim to be. That's what we've been for 35 years. That's our wheelhouse is vacuum, all things vacuum. So it's always interesting because when you're talking to someone who doesn't understand or know about vacuum heat treating, they think you actually make a product, that you're in some way a manufacturer. But really, we're a glorified dry cleaner, or fast food house or a bakery. So we don't actually make anything. We take somebody else's dirty shirts, we clean them and we give them back, but with giant pieces of metal, ceramic, etc. So helping people to understand that first, that this is a service business as opposed to producing a tangible product. Once we get past that, then it's all easy, right? So for vacuum specifically, it's clean, easy to control, and safe. Right? The results are clean and it's shiny parts and it's minimal distortion, and it requires comparatively little post-treatment finishing or cleaning. The goal is to eliminate oxidation problems, basically by performing the operation in a vacuum atmosphere. So if you think of a normal furnace, even the oven in your house, it's got an outside and it's got an inside, and the inside has, you know, the elements, and that's where the heat comes from. Vacuum furnaces are actually really close to your oven at home. So it has the outer shell, which is sealed, and then it has the internal components. And the internal components are where the heating elements are, and those can be made out of various materials. And then we can precisely control the atmosphere, lack thereof, to introduce inert gases, to have different quench rates, all to minimize heat-induced distortion, decarbonization, reduce contamination, oxidation, and it doesn't produce toxic or combustible waste. So it's safer and more environmentally friendly than some of the liquid quenching processes or other processes. So, you know, the basic structure of a vacuum furnace, once you've got the outer shell, you've got the inner shell with the heating elements, and then you've got a series of pumps. The pumps are what evacuate everything that you're trying to avoid staying in your furnace while you're processing parts. So you've got the holding pump that's going to pump down to a minimum level of vacuum just to get you kind of baseline, make sure that everything's cool.
The goal of pumping is taking the oxygen out from the chamber.
Taking the oxygen out, any contaminants, and getting that baseline vacuum level ready to go. Yeah, absolutely. So then you switch over to your mechanical pump, and that's the real horsepower, right?
Okay.
That's what, that torque that you're talking about, you know, 1 × 10⁻⁵, 7, etc. So once you get there, you've got a perfect atmosphere in which to process your parts. You're surrounding the product in the furnace by a vacuum during processing, which the absence of air and other gases prevents oxidation and heat loss through convection, and removes any sources of contamination. So you can heat treat materials, typically metals, ceramics, etc., to very high temperatures, you know, 5,000 degrees F. We don't necessarily go that high. We do about 4,700, but the furnaces obviously have different capabilities depending on what you buy. And also the furnace and vacuum levels depends on your melting point, your vapor pressures of your materials. So we have the ability to custom design a lot of those variables out to create an extremely uniform process that's commercially available to anybody. So that's kind of the nutshell of vacuum heat treating. I know I went through it fast though, so.
It's fantastic. I think you described it well. You described actually a single chamber furnace. Am I right?
Yeah, single temperature. Yes, we can do, we personally, and vacuum furnaces themselves are capable of a wide operating range, typically down from 500 degrees to 2,500 degrees is kind of the sweet spot for vacuum furnaces. Vacuum furnaces do not like to operate at lower temperatures.
They do not.
They do not. No.
And
The higher the temperature.
Why would that be? I didn't know that one.
Well, with certain materials, when you're in those lower temperatures, you're going to start producing some of the outgassing, right? So if you're only getting to outgassing temp, you're basically vapor depositing a bunch of crap on the cold wall of your furnace. So they don't like that. It degrades them quickly. It produces a lot of contaminants out of the parts. So we like to rapidly go through those lower temperatures, hit the stabilization set points up and up to get to that final temperature to experience either very quick outgassing or minimal outgassing.
And can you help us describe a typical cycle for a vacuum heat treat? Since you actually load the parts in, you close the door, and then what happens?
So when you have a vacuum furnace, you want to make sure that that seal is there because your furnace door is a source of leaks. So you've got a sealed shell, but that sealed shell has a hinged door. So you have to make sure that your O-ring is completely sealed. So you got to make sure you check and make sure it's not degraded. You have to make sure it's not torn or
How do you test that?
Well, you can leak test your furnace, right? You can pump it down to a minimum vacuum level. You can run a simulated leak for a period of time to see how predictable your furnace output is. We do those every week after our burnouts. So you can do a temperature burnout followed by that simulated virtual leak. That's a great way to ensure that your vacuum system is performing optimally. So once you have to do that in your preventive maintenance, though. That's not an every run thing. So
Right. Like a weekly checklist or something.
at least, yeah, a minimum. So I know NADCAP specifies that you have to have a preventive maintenance program, but we kind of go above and beyond on that.
Mm-hmm.
Because we know that taking care of a piece of vacuum equipment is going to allow that internal to last a lot longer. So the average life of a vacuum internal is maybe 10 years, but we can get up to 20 years because of our preventive maintenance program. So making sure that we are doing all of that to ensure that we're taking care of that vessel is really critical. So that was a tangent, sorry. So back to the furnace cycle.
You can go as tangent as you want. We got time, no worries. I told you were passionate about this before we start recording, so.
I know, I can't help it. It's my first love, it's my only love. Outside of quality, I really just love everything about what we do. So if I get too far off, you're gonna have to rein me in.
I will, don't worry.
It's very important. So grease that O-ring with some vacuum grease, seal it up, pump it down, and then program your cycle. So now that the new AMS 2750E has come out, we're completely away from paper charts. We're in all digital land. So you're programming your controller to do what the cycle is that's required by the customer. So, for us, we have several stabilization points built in at the lower temperatures where it'll equalize and get to a uniform vacuum level where you're not seeing any outgassing or spiking.
How much time will that take to get the furnace from the time you actually close the door to have a vacuum there?
To have vacuum an hour or less.
An hour or less, and yeah. Do you do that with some temperature at room temperature?
We always have temperature. Yeah.
Okay.
Vacuum furnaces like to be hot.
Okay.
Our first hold temperature is at 500.
Okay.
So second hold at 1,000. So in there, you're equalizing to your vacuum level at that point. So our minimum vacuum is 1 times 10 to the minus 5. So we don't like to work in anything less than that. You're going to get a whole bunch of issues if you don't have good vacuum. So once you've equalized out at those different set points, you're going to ramp up to your final set point. So for brazing, you've got to watch out for the liquidus. You want to get in and out for brazing. So that time at temp is typically very short, between 4-6 minutes, depending on part size. But spending time at liquidus when you're brazing, it will allow the alloy to flash out further through capillary action. We do not want the alloy to travel a whole lot. So once we hit that liquidus, it ain't quench it. Let's go. If you're not brazing, if you're just heat treating, so you have a parameter where you bring your low thermocouples, you're watching your glorified thermometers, right? Thermocouples are just glorified thermometers stuck into the parts.
Do you have to have thermocouples by load? I mean, on the load? Is that a NADCAP thing?
It depends on the type of furnace instrumentation.
Okay.
Furnace type instrumentation A, B, C, D, and some extra special types in Rev E now. So it depends on what you want to have in your shop. So for our requirements, all of our instruments are Class B, which means load thermocouples. Yes, we run loads, we have a control, we have an overtemp. So between those three, you have a system that is completely validated to make sure that even though your furnace says that you're at heat, you're actually watching the behavior of the parts, because
that's right.
That goal, right? Making sure the material sees the heat required to transform and enhance, etc.
So we close the door. We pump everything that is actually inside the furnace, and then we go to temperature. What's the average time that we actually leave the load to homogenize before we quench it?
It's going to depend on your load size, obviously.
Okay.
If you've got a small furnace load size, you've got 3 little tiny pieces in a box. Your temp is going to come up much quicker, and you're going to be able to start counting off that time at temp much faster than 1,000 pounds of steel, clumped together with not much room to get that heat down to the center. So it can be anywhere from 20 minutes to 18 hours. It just depends on the type of material, the load size.
18 hours. This looks like a carburizing cycle.
Yeah, we have vacuum furnace cycles that run, I think our longest one is 38 hours.
38 hours.
Yes, and
and
that's
what
for
would
one of
that be?
that's for one of those special companies that shall not be named in the defense and space business.
Okay, got it.
Yeah,
And
they like to drive fancy cars to space.
why would that? Well, why will a spec be so long? I mean, what would be the material science issue?
Well, we're not dealing with metal in that particular.
Okay, okay.
So you're talking about an overall degas operation there.
Mm-hmm.
You just need that time attempt to make sure it's fully degassed.
Fully degassed. Okay, so that's the thing. Okay,
Yep.
so when we actually now we have the part at temperature and then we quench. Can you explain us the quenching process on a vacuum furnace?
So the interesting part of that is on the quench, you can control a ramp rate. So you can control how fast you get to heat. Once you've triggered over into that cooling operation, then you're hoping that your furnace and your load behave predictably, right? Because you can't really program quench rates. You can introduce the gas at an appropriate time. You can control how much gas you put in there. You can control the exchanges. But from there, you're hoping that it does what it's supposed to do. So your cooling rate, typically, if you're doing transformation cycles, you're asking for a very fast rate, high temp to a low temp within a very short amount of time. So you have to introduce more gas, making sure that it's fully circulating and getting everything cooled as fast as possible. So if you're just doing a regular controlled vacuum cool without, adding any argon or nitrogen, helium, then you're just waiting for the parts to cool down on their own. But if you pull parts too hot on a vacuum furnace, the minute you open that door, you're potentially introducing discoloration, oxidation.
Okay.
So you don't want to pull parts hot from a vacuum furnace. So we don't open our furnace doors until it's below 200. It can take a while.
And you mentioned three quenching medias. You mentioned helium, you mentioned nitrogen, and
argon.
argon. Which one do you have most experience with, and what are the differences on quenching with each? I know helium is super expensive.
Very,
right?
Yes.
And I know that there's some helium recycling recovering systems that are also super expensive. So
Yes.
I don't know which is the pros and cons of using which. I don't know if you could share that with the audience.
Sure. What we do mostly is argon.
Argon.
Not commercially available argon. It's not the ones that are in the bottles that you use for weld gas or some other application. This is ultra high purity, 3 nines, extremely low oxygen content, moisture content. The dew points are extremely low. So that's the quench media that we prefer. And most of our furnaces, actually all of them currently are on argon. But we have the capability of doing nitrogen very easily. The switchover process is very time consuming because you have to do a complete purge to make sure. And we also work a lot in hydrogen. We do atmosphere heat treat as well. But we're focusing on vacuum today. So argon is the best. Everybody uses it. Helium is extremely expensive and it's rare and hard to get. But sometimes you've got the specialty jobs that require it. We haven't actually had a helium quench in probably 15 years at this point. Nitrogen is much cheaper and behaves similarly to argon. So if you're going to go with a gas that's cheaper and more readily available, definitely nitrogen's your choice. You're going to get fairly good results and not have to worry about it. But for those space and defense projects, they are considering argon as the gold standard. And so
do they specify argon as their quenching media?
Not necessarily.
They just give you the spec of material on case hardened or core hardness, and
yes,
and you can choose wherever you want to quench with helium, argon, or nitrogen.
And that's the nice part about heat treating. So sometimes the customer doesn't even know what they want. So we get to partner with them to help them design the best possible outcome for their parts. And they've got all their money in it by the time it comes to us. You know that, Carlos.
Well, it depends. I have a different opinion because sometimes the customer, and I'm an old guy, I do quenching oil, and we're seeing that salt is getting more and more popular, salt quenching. We had a great podcast with Chip Keel on the tempering process, and some of the guys go like, I need this being quenched on salt, right? I go like, well, I do not have that machine, but I'm pretty sure with the oil quench, I can actually give you that spec. And they just don't want it. I mean, they go like, it's a tempering process versus carburizing oil quenching temper, right? And
Yes.
you can heat it, but customer doesn't understand it. So for me, has been the other way.
Yeah. And getting the government to change something is a battle in itself. Getting a customer who has a tried and true process for maybe 50 or more years, because heat treating is not a new technology. It's actually pretty old.
It is not.
Yeah. So if it ain't broke, don't fix it. Like, don't mess with my stuff. Why are you wanting to change it? They don't necessarily understand that it could be to their benefit to consider some options, especially as more technology becomes available.
So let me ask you a question that, since you're in California and there's a lot of modern manufacturing there, right? I have the belief that heat treating does not evolve as quick or as fast as machine shops or let's say forging or you name it, because furnaces have just a lot of lifetime, right? And so if you maintain them properly, like we just talked about, they can last forever, right? They're just vessels. And what has really been like the modernization of furnaces has been the controls, right? Like taking out paper charts and put an HMI or something.
Right.
That has been the upgrade, but there has not been like a significant change on the vessel itself, right?
Right.
So and if you see the evolution of machine shops, of machining tools, of the tooling in the last 100 years, you will see that we're very far behind from looks now and what it used to look now. I'm actually going to do that study. I'm going to Google machine shops in the 1900s and heat treat shops in the 1900s and nowadays, and I believe we're going to see a lot more evolution on machining shops. I don't know what's your opinion on that.
I agree with that because there's a lot of automation potential. Manufacturers were largely human dependent. They required hands, to move tools, and when we've evolved into, AI routines and getting machinery involved in robots that can take the place of those humans, there's a lot more potential there.
And you being in California where, automation and AI is like a big thing. What's your exposure heat treat wise with automation? We have talked about it in another episode of the podcast regarding the thing with having robots on plants loading and unloading because our fixture gets very distorted and robots have a little tolerance. So have you seen that? How could you automate a cell vacuum wise? What's like the area of opportunity?
There's a lot of different loading systems that can be almost fully automated. Instead of requiring 5 furnace operators to run 5 vacuum furnaces because they have to physically walk location to location, centralizing it all to a computer control room, essentially, that runs the digital equipment. They can program and run furnaces from anywhere in the world. They don't have to be standing by that vacuum furnace. So I think that's been a real progression for us, especially if you're spread out over a big footprint. We've got 12 vacuum furnaces over 45,000 square feet. So they're walking 2 football fields trying to run back and forth. That's just not possible anymore. So getting into some of those automated loaders where they're on the tracks and they can run back and forth. Actually, I just watched a really cool video on that. To minimize the humans lifting, pushing, pulling, and pushing buttons, that's the opportunity to maximize your capacity, your utilization percentage, minimize the downtime because idle furnaces don't make you money. So that's I think where the investment opportunity is.
And you have been one of the very few actual heat treaters. We have had some guests which are suppliers or experts on other subjects, but you actually do run a commercial heat treat company, right? Yeah. And I asked this question to John Hubbard. Is there what KPIs will you believe are the ones that need to be addressed running a shop?
Mm-hmm.
What would you say are the key things that you have to wait to watch? Of course, utilization of the furnace. You just told me the first one, right?
That's it. Equipment downtime. I mean, the minute your furnace is done, you got to get something else in it. Otherwise, you're losing dollars. And having an understanding of the burden rates associated with each furnace is really important. So being able to analyze at month end exactly how many kilowatt hours of energy it's requiring to pull from the grid, and what's the maintenance required, what's the downtime, all adds up to kind of this picture of how profitable is this particular piece of equipment and how many times can I multiply that to get the revenue goals that I'm after. I mean, it's simple plug and play math, right? You have one vacuum furnace can do this capacity, let's multiply it. So having a good understanding of your energy requirements, there's a lot of programs out there now, and we're adopting a peak shaving technology to kind of level out our burden from the grid for that reason. So understanding what you're pulling, what you're producing, I think managing the labor hours as well, because the machinery hours are different than the labor hours. So knowing the output from each person and what that's producing for you as far as hardware, parts per million, et cetera, equates to your revenue per employee. So to maintain your profitability, I mean, you've got to be pretty high on that per employee ratio. Our target is 15,000 a head, but that's low even now.
This is now CEO talk. You know,
yeah, sorry.
this is CEO. This is not the CEO podcast. This is the Heat Treat podcast. You know.
All right.
No, but you know, it's and I gotta ask this. So, you work in a family company, right?
Yes.
Well, I believe you first learned the technical aspect of the business, and then and you're a very successful woman, but you keep learning how to be a better CEO day by day.
Mm-hmm.
But you have a very strong technical base.
Thank you.
No, I mean you just switch from very technical and going quenching and stuff to you know, revenue per guy and stuff. So you know, that speaks a lot of respect for you. You know.
Oh, thank you. We're just baking glorified metal cookies over here. It's all good. Just running big ovens.
No, I got a question though regarding how you actually track energy, because
Yes.
I have the same problem, because you mentioned you have 12 furnaces. I don't know if they're identical, right?
They are not.
They're not, right? So you have to be measuring the energy per unit, because
Yes.
what and I run gas, right? And a lot of customers actually have this misconception, right? Just take your gas receipt and divide it by the number of furnaces that you got.
That's a start, though.
That's a start, but it gets way more complex than that. You have to measure each unit, how much energy is actually consuming.
Yes.
But as well, there's different processes with different requirements of energy. Maybe you're rolling very high temperature, or you're using more argon or nitrogen on one quench side.
Right.
Maybe you can have very few parts, or the other one, they can have a bunch of parts. How do you track that? I mean, how do you go, not just taking the electrical bill receipt and just divide it by 12?
Well, we did that. That's where we started. So
Just
I'm trying to say we were very fancy back in, you know, the early days, but yeah, that's the easiest way to do it. Take your electric bill, divide it. That gives you a baseline, right? Start doing different things. So we have a very close relationship with our energy provider. For us, it's Southern California Edison. And getting to know your account manager and knowing what programs are available to you as a high energy user, they actually want you to be aware of your usage. So sign up for the peak demand shutdowns. It's the best way for them to give you free technology stuck on all of your furnaces so you can understand what everything is producing. Or you can sign up with one of the different providers that focuses on this, like InLX. I don't know any others that are providing solutions off the top of my head. It's different in each area, but you know, you're taking your aggregated anticipated capacity and then you're generating a payment rate based on that and how much you're able to reduce the demand. And they provide you with technology that says which output is coming from which furnace. It's a great way to get capital investment without, forking it out yourself out of your own dollars. So I would recommend putting in, one of those programs to get an understanding of what each individual furnace is doing and during what times of the day. Because everybody knows.
Does that matter during what times of the day?
Absolutely. Just like when you run your air conditioning at home and you get the notice from your provider saying, hey, these are peak demand hours, try to reduce your energy. Don't run your dishwasher until after 9 o'clock at night. It's the same thing with vacuum furnaces.
Do you have to schedule your loads based on peak hour demands?
It depends on how big you are.
Okay.
So some companies are small enough to where they can adapt their demand and their utilization to accommodate off-peak energy timing. Once you get big enough and you have enough revenue flowing through, they kind of give the middle finger to that and they just keep on rolling. So it depends on what your goals are. We've done both strategies. We've done the summer hours, we've done winter hours, we've gone through that evolution. And at this point, we sign up for incentive programs. And if we are able to reduce and shave demand, we take advantage of that.
Now, I wanted to ask you this, but maybe this is a misconception regarding the vacuum process, because you just told me that vacuum furnaces like to be hot. But I kind of got the idea that because I run atmosphere,
Right.
But whenever you're running parts, you're still using energy.
Yes.
On vacuum furnaces, when you're done, you actually quench on the chamber, but the furnace is not utilizing energy if you don't have a next load to follow the one on the chamber. So will that be true? If you're not using the furnace, it's not costing you as much money because of course there's depreciation on it, but as if you were actually running for an atmosphere furnace. I believe that's a pro on the vacuum side.
It is a pro to an extent. So it's not an on-off switch. Vacuum furnaces do not do well if they're all the way shut down. It's not good for the equipment to have it completely turned off. So when we don't have loads in there, they are pumped down and they're idling because it helps maintain the equipment. It helps keep the vessel contamination free. So it's a reduced demand, but there is baseline demand for a furnace that's idling.
And what will be a typical preventive maintenance of a furnace? Not a weekly. You just got to check the vacuum seal.
Right.
What else do you check maintenance wise?
Well, there's different things that it depends on how much equipment you have, how many people you've got, and how much you can get around to these things. But we have both daily maintenance and quarterly maintenance. So on the daily maintenance side, they're just making sure, they're topping the pumps off with oil. They're making sure that they can still read all the instrumentation. They're making sure that they're greasing that O-ring every single run. They're checking the mechanical pump level. They're verifying the temperature is okay. They're checking the diffusion pump to make sure the sight glass is available. Checking the blower oil. I mean, there's so many different things. You have to make sure you inspect the condition of your hot zone to make sure it's not arcing. It doesn't have any broken elements, or it didn't break your hearth or have something, a broken shield. Making sure that your gas inlets, the cooling ports, are totally free of obstructions, because that's how you get everything quenched the way you need it to. You've got to verify your clamps on the inlets are tight. Make sure you're not getting any leaking gas. All of your lights on your panel are lighting up that are supposed to. We do ballast our mechanical pumps and our holding pumps. Only when the high vac valve is closed, obviously. But checking your water and air hoses, furnace tooling. You don't want to put discolored baskets inside of your bright, shiny, clean furnace internal. So checking your loaders, drain water. I don't know how much you want me to keep going.
No, I mean, there's a bunch of, yeah, I see that you're actually doing the checklist. So that's good to know. Let's talk about fixturing and racking. And I'm not an expert in any way, the alloy of baskets and racks that we use is actually all castings,
Mhm.
HTHU, right? But I have seen that graphite is very famous for vacuum.
Yes, we use a lot of graphite. Yeah.
Can you explain why graphite and not castings made of alloy? If what material is the tray, and if you have a special tooling or you just go standard? Because when you're a captive, you can have a special tooling for a bunch of same part numbers, right? But when you're a commercial, you want to have baskets that are flexible. You want to have different layers. Uh, can you explain us a little of what makes sense to have in as rackings, and I don't know if you use trays on the vacuum process, right?
We do, yeah. We have trays, we have baskets, we have individual racks, we have graphite boards, graphite with holes punched in it. We've got, I mean, pretty much any configuration of tooling you can think of. So it all depends on the material that you're doing, the processing that you're doing. So graphite holds heat, so you got to be careful if you're sticking a big load on top of graphite. Graphite sucks it in and holds it on. So it's a good material because you don't get a lot of eutectic bonding. You can get eutectic with some of the other materials like our baskets or RA 330 for the most part. And you can get some diffusion bonding from having that metal to metal surface contact. Graphite doesn't have that, so it does help with that. Also, graphite can be machined just as easily as other materials. So you can create more customized tooling, and graphite can be a cheaper option depending on what you're working with. We build custom baskets for customers all the time. It's dedicated tooling. It's only used on their parts. It depends on the overall customer's goals. You know, if they want to invest in the process up front, we are happy to get with them and design custom tooling that's going to be the best for their application.
And what I do when there's a customer that actually requires like a special tooling itself,
Mhm.
And this is my the companies I run, right? But we tell them, you guys pay for the tooling is yours, and
Mhm.
we'll happily storage it for you, right? But we do not actually price that on our per unit price, right?
Mhm.
Will that be the same with you, or do you price it?
It depends on the customer application. So working in defense and aerospace, a lot of times you have to deal with very specific requirements for government-owned tooling. That's a whole different world in itself. So you might want to own that tooling, but there's no way the government's going to let you own that tooling. And you're going to have to maintain it or at the very strict protocol and audit it and recall it. And you got to write a 10-page procedure to manage your furnace basket. So we've got that all the way down to, yeah, we got a graphite, throw it on there, no problem. And it's priced into your, general cost of goods sold kind of thing.
So before we move on to the other industries that like defense and deep space exploration, I would really like just to finish the vacuum process with like we haven't talked about distortion, IGO, and the tempering process, right?
Right.
So vacuum is well known to control distortion, right? That's like the big thing.
Big selling point.
That's the big selling point. Also, that is pretty clean. That doesn't need a post wash, and of course, the IGO, right?
Right.
So, just can you share just your thoughts and your comment regarding these three items?
Yeah. So tempering benefits from vacuum, annealing benefits from vacuum. So it allows for a more uniform grain structure by using vacuum because you can control everything very precisely. So if you're looking to achieve optimal levels of hardness without it becoming brittle, vacuum furnaces are a great option for that. That's primarily for like cutting applications and things like that. You need more wear resistance over time. If you need additional abrasion resistance, vacuum tempering is a great option for that. It balances out, the hardness, and you get greater levels of the ductility. It just depends on your needs. But with vacuum furnaces, you have complete control over your processing in a low contamination environment, flux free, extremely clean. So, right?
I got a question. After you quench a part in a vacuum furnace, do you
Mhm.
temper the load on the same furnace, or do you have to switch furnaces?
You do not have to switch. It depends on the operating zone of your furnace, obviously,
Hmm.
or the qualified operating temperatures. So as long as your cycles match up within your qualified operating temperatures, you can do multiple cycles in the same furnace. Yes. We do that a lot with materials that require, a triple temper plus cryos in between. So that goes cryo back to the same vacuum furnace, 3 different times. Totally capable, totally possible, and easy to manage.
Well, now, what are the, and I don't want to focus on the negative, but when does vacuum is not a choice for the application? When do you have to let go of a job because the process is not it doesn't receive the parts well?
So you've got to understand your customer first. So not every customer is going to be a vacuum customer.
Mm-hmm.
There is a price point that comes with vacuum. It's going to be more expensive than running something in air. It's going to be some more expensive than running in an atmosphere or polymer or salt. Vacuum, very complicated equipment, very high maintenance. It's not your low cost leader. We're more of the Nordstrom than the Walmart. So making sure the customer understands right out the gate that they're not chasing price here. If we're looking for penny per pound heat treating, we're going to send you over to our Santa Fe Springs location where we got oil quench and temper for you.
So send those to me.
We'll work that out.
Say, all right, I'll give you a commission.
It's all about making friends.
All right.
So once we understand that the customer's price point is right for vacuum, then we actually make sure that the material is not going to degrade the furnace. So a lot of these non-metal parts, your plastics, your silicones, you don't want to necessarily put that in your furnace, but you're going to pull out a lot of contaminants and you're going to deposit them on your cold wall and start degrading your internal very quickly.
Mm-hmm.
Sometimes that's okay. If you buy into that and this furnace is dedicated just to running stuff that's really gross and pulls out oil and grease, and as long as you buy into that and that's isolated, more power to you. But it's very difficult to keep vacuums clean unless you're focusing on material that belongs in vacuum furnaces. We tend to kind of specialize in the super alloys type of environment. Inconels and Hastelloys and that sort of stuff. We don't necessarily want to run, 1018. It's not going to, there's various materials that vacuum's not applicable for. I don't want to get super technical there, but part of the contract review and engineering analysis that happens up front to make sure that vacuum is the right application for what the customer is asking for.
Mm-hmm. And now I'm talking to Heather CEO, because they say
okay.
that let's switch, because it is said that the CEO sometimes is the best salesman, because he knows what doesn't run with the infrastructure. Well, it might run, but it's not in the best interest of the company, because sales guys, they just want to hit the numbers and selling everything, right? And even if it's a very, very interesting project, like this is going to harm our furnaces. This is going to take a bunch of labor from us.
Yes.
Or this is very lab testing intensive, price it up, right? So I hear you, I totally get it, right? So thanks for sharing the vacuum process. Now, we'd like to ask you, because I have no exposure at it, at these two industries, the defense and the deep space exploration industry, right? Are they similar to aerospace? I have seen that you're very big on NatCap, on thermovac. Are they run by this quality system as well? Can you share a little, super classified? They make you sign a bunch of contracts and stuff.
Yes.
Do you get to see some weird stuff? I don't know. Can you tell us how are these industries?
The industries are exciting, astounding, awe-inspiring. When you see literally a space shuttle taking off that has people inside of it going potentially to another planet.
And you go like, I'm a part of it.
You almost get like goosebumps, you get a little teary. I mean, you take it straight to the heart, you know, because you're the difference between life on Earth and life on Mars. And the heat treater is a big part of that. It's not just the SpaceXs and Blue Origins and Virgin Galactics and NASA. It's not just those big guys, because they're all dependent on a very advanced and complicated interrelated network of suppliers, largely small businesses. So for us to get to play with these big guys, we're the ones that make them go. Mm-hmm. A lot of people don't realize that. You know, the space shuttle is built by the lowest bidder. You know, people don't know that either. The cheapest price wins for the space shuttle. It's unbelievable. But to play in the aerospace and defense world is a different ballgame. When you're dealing with just commercial heat treating, there's not necessarily as many specifications and requirements that you need to adhere to. You kind of have a little bit more leeway. Best industrial practices. It helps you maintain or to be a little faster in your lead time, right? National Aerospace Defense Contractors Accreditation Program. So they obviously all got together in a room back in the 90s and said, hey, we all got to get on the same page here, because if we're going to get past the moon, everybody's got to play and everybody's got to up their game. And what worked in the 50s is not going to work in the 2000s. It's not going to work in the 2020s. Right now, we're trying to get back to the moon and beyond. I mean, Artemis with SLS Orion, you know, we've got Elon Musk trying to get to Mars. We've got Perseverance that just landed and is sending all these cool pictures. So we are truly in a resurgence of air and space that harkens back to those initial Apollo missions and when space got really sexy and the president was excited about it. So it's a great time to get into defense and aerospace if you understand what you're getting into.
Right. And I don't, well, maybe in defense it is, but are the volumes any big, or should maybe for the space program, do they give you like a load of 50 parts, one part, 200 parts to heat treat at a time? Because we have talked to many automobile guys, and the volumes are just massive, you know, millions and millions of parts. How are the part volumes in these industries?
Spaceships take just as many rivets and screws and nuts and bolts as a car does. So, but they're processed entirely differently. Aerospace bolts and automotive nuts and bolts, although CQI-9 is very much advancing.
Why would you say that?
I think that they're getting closer to the aerospace standard personally. And in some ways, CQI-9 is superior. I shouldn't say that. That's blasphemy. I think that they have some process control components in CQI-9 that far outweigh what NADCAP's doing. So
that's the first time I actually heard this, because, you know, I'm a CQI-9 guy, I'm an automotive guy, and there's also this NADCAP taboo that you know, I run, and don't get me wrong, CQI-9 is it's super technical, and I believe they do a great job, you know, making sure everything goes well and there's traceability, right? But there's always the belief that NADCAP is 10 steps ahead. Yeah. So that actually shocked me. So have you said, well, and I don't want to put you on the spot, that let me make sure I don't say something I can't compromise with you. So you're saying that CQI-9 has evolved faster than NADCAP has done it.
Right? I believe that. I think there was more room for that to happen, though.
Okay.
In NADCAP, the standard was already, you know, we're talking in degrees of sigma, right? They're already they're dealing in infinitesimal changes. Now, when 99.999 is not good enough, that's what NADCAP's working in. So with CQI-9, they had a lot more evolution space.
Oh, yeah.
So I think that's why they were able to progress like they are, because essentially we've gotten to a point where NADCAP is working in such small adjustments that the tangible return on investment can't be seen as easily as with automotive. You know, you have millions of cars on the road. You have a much bigger sample size than the number of space shuttles that have launched. So if we're looking at relativity, the process control on the automotive side is you know, comparable or even greater for in regards to human life and technicality and executing repeatable, first time, zero quality, zero defects, zero escapes mentality.
Well, and the fact that Elon Musk is aiming through reusable rockets doesn't help you out much, right? Right.
Rockets is a real sore point for us over here.
Yeah. Well.
Yeah.
So when something blows up, like, oh, like, well, there's more heat treating for me. They have to build a new one, right?
Well, and reusable is a relative term. A lot of the components on a reusable rocket have to be replaced after every single run. So
that's the selling point to NASA. Those are reusable, right?
Yes.
Right.
Yes, that's what they're hanging their hats on, is cutting down the cost because of reusable engines, particularly.
I'm sure they're cutting down the cost a bunch just by reusing, I don't know, 30% of it.
Yes, at least.
That's a bunch of money.
Absolutely. And then add 3D printing in, and now you're really talking about driving costs down. So.
You know, when they talk about 3D printing, I believe us as heat treaters should be worried way more because of additive manufacturing, 3D printing, because that might disrupt the industry, the material science. Maybe they can create a metal or a material that doesn't need heat treating at all.
That's what I think is going to be the tipping point. If they keep the need for hipping to get rid of the porosity out of additive manufactured materials, that's going to be the game changer. Until then, they need us. It's full of holes.
It is. And I'm sure there's a bunch of startups in California that are doing 3D printing stuff. So
I love it. I love disruptive technology. We live in California, land of disruptive technology. Valley, we are ready for change. We're Tesla, we're SpaceX. It's time for things to be disrupted, because that's the only way that we get outside that comfort zone and get into some of these new amazing discoveries that are right in front of our faces. Okay,
so just want to change the topic just a little and go away from the heat treating side. And I'm reading here on your CV about you being recognized for being is it an organization, the Women Leaders of a Family-Owned Business, W Life? What's that?
So W Life is Women Leaders in Family Enterprises.
Okay.
There's a niche within a niche. So small businesses are already niche, right? But the amount of women leaders of those businesses is what I would term as an underserved community. There are not a lot of us out there, and we are not connected to each other. So Life was established to collaborate that very specific population together to provide mentorship, opportunity for peer-to-peer conversations and best practice learning, and getting people involved in bringing the next generation into a women-led organization. I think we have a lot of opportunity at this point to transform generationally. So when you think of a woman leader, there's still, I hate the buzzword stigma, but we're going to use it because I don't have a better one. There's still a stigma for women-led businesses. Oh, they're a little bit on the softer side.
What will be the stigma?
They're not as serious, right?
No.
Yeah, don't take them as seriously. They're more, they're going to do the fluff pieces. They're going to, they're all about, love and kisses, and, it's just not the case anymore. It's just not the case. There are women out there doing serious business, and if anything, they can be a cutthroat. So
I'll tell you what. Whenever you're totally right. There's more male CEOs than women in the world. But whenever I have to negotiate on the counter side with a woman, and I know that she's really professional, I know I get intimidated because women have this strong personality, and it's I think things are going to balance in 3 or 5 years. And I remember I listened to this in one lecture that the success of many companies will be actually on hiring a lot of female power, just to get that diversity and
Right.
also the strengths that women bring to the table, right?
Absolutely. Well, diversity and inclusion is the buzzword from 2020 with BLM, with George Floyd, with major corporations jumping in and saying we are taking a stand for what we believe in. Diversity and inclusion is here to stay, and it's only going to get more in our faces. So,
But talking about women and men, I believe we're wired different. So if you have like a brainstorm session with only men, right, you will get very square ideas, right? When you have a variety of brains working, female and male, and you're trying to solve a problem, I believe you can get a much more better solution, because you're having two types of brain, working for the same goal.
I think it's interesting that you mentioned that, because it's even beyond men and women, right? Including diverse backgrounds, people that have had different life experience and opportunities and exposures that goes beyond gender as well. Making sure that you're truly looking at involving every scope of the world that you can into your business. It's going to help you be more well-rounded and make better decisions, exactly like you said.
And even age, it's always good to have a young guy, an elder guy, and maybe a guy in let's say in their mid 40s, right? Because they think different, right?
Yes.
The younger guys are super dynamic, great with computers, right? But they think they know best from the guy that has been heat treating stuff for 40 years, right? And the other guy might know a lot of stuff, metallurgical wise, how materials behave, but he doesn't get the computers as much as the young guy. So you can actually bring that balance, and imagine if we actually add genders to that one. So you have a lot of I don't want to call it diversity, but you got a bunch of different brains with different backgrounds actually working as a team.
I think diversity gets a negative rap. Whenever you think diversity, you think of something to cover your ass, right? You're doing it because the lawyer said so you don't get sued. And that's not what we're about. It's exactly what you said, Carlos. You're just trying to get the best section of the world in your business to help you solve the complex problems that is going to make everybody money, make everybody happy, and ultimately get this world a better place. I mean, we all have this lofty goal of contributing in something that matters. And I think diversity is a great first step to really making something that matters.
And also you mentioned, well, this is before the interview, that you love promoting growth and opportunities outside people's comfort zone.
Yes.
And the way you mentioned is your passion. So how do you work with that? Because right now the phrase get out of your comfort zone is really popular, right? But it's something to say it, to do it for yourself. But you specifically mentioned here that you like to coach people and promoting people to get out of their comfort zone. How do you? I just love that. I think that's the way to lead. So can you share with us what do you do with your employees, friends, colleagues? How do you take them out of their comfort zone?
Sure. It starts by working with people that buy into why you're doing it. So people don't buy what you do, they buy why you do it. That's what Simon Sinek says. It's a great philosophy to start with.
I love Simon Sinek.
He's my favorite.
Oh, yes. The infinite game.
Yes.
Start with why.
Yes.
What's the other one?
Leaders Eat Last.
Leaders Eat. I haven't read that one, but I love to watch his TED Talks and everything. So
you already
great. I like you even more now.
Yes, we're on the same page, because with the infinite game, the goal is not the goal of the business is not money. It's not profit. it's evolving over time and getting people skills, advancing and getting people to contribute to something that can truly be world changing. So if you start with why, to get people recruited into that concept, that's the basis of getting out of the comfort zone. If you want to show up and sit in a cubicle and make the same that you've made for the last 20 years and use the same programs that you've used for the last 20 years and do the same thing, that's not what we're looking for. But if you come and subscribe to what we're dealing, then we're going to offer a different way of looking at things. So when you've got somebody sitting in front of you, they have a natural set of biases, right? They have a natural sense of self that includes inherent limits, the I can'ts or I would nevers, or I never even thought of it. So getting them in front of you and saying, well, what if you could? What if? Mm-hmm. What would another answer be?
And people like to be challenged. Whenever they're challenged, they have something to wake up in the morning for, right?
Yes.
And when you lose that hunger that you're not being challenged, you start just fading away, right?
Yes.
So it's really, I just loved it when I read this. So now going to one of my to the next thing on the show, heat treat gadget or a heat treat hack. Do you have a heat treat gadget or a heat treat hack that you use on your career?
My career. It's hard to narrow it down because I think overall heat treaters take themselves a little too seriously. Mm-hmm. Put that out there in the universe. So if we're talking about a hack, it's calm the F down, guys. We're all in this together. I mean, there's enough business around here for everybody. I get that we're all looking at each other as competitors, but the way that we get this disruptive innovation in an industry that's hundreds of years old is not through this, us versus them thing. So if I'm talking about a hack, I'm talking about start collaborating with the people that do what you do. Go out and talk to them. That's MTI, right? Mm-hmm, mm-hmm. MTI is one of the greatest sources. And you go there and you learn from each other and you establish best practices. I would say that a big hack is go get involved in your industry specific associations, whether it's AWS, whether it's SAE, whether it's AMEC, MTI,
and that's where I bet you.
That's right.
I feel 100%. That if you actually network with the guys that do what you do, mm-hmm. they can be competitors, friends, mm-hmm. or as I like to call it, colleagues. Like, right. I don't compete with your heat treat shop, but mm-hmm. I don't do what you do. Mm-hmm. But you just can. We can learn from each other, right?
Yes.
And I don't promote it, but I try to have a healthy relationship with my competitors. Mm-hmm. when we had the gas the gas thing with Texas that we didn't have any gas or something, I just called them and say, hey, I'm doing this. Or we have a power outage or something goes wrong, and mm-hmm. I just call them and say, hey, I'm doing this. What you doing? And they'll be happy to share it. But we're not like we're not friends, but we know mm-hmm. we can rely on each other. I don't know if that's what you mean.
It is, and not to be afraid to reach out to people of like business types. A lot of the big primes, when you're playing in the aerospace or defense game or space game, they require business continuity plans. So if your facility goes down, where are you going to process my parts? Developing a relationship with someone that does similar business as you, to create that collaboration and that continuity now gives you an edge. You have a competitive edge to take to those primes. Hey, by the way, I've got a fully functional facility that's completely going to be up in case we go down. There's so much opportunity, especially with all the opportunities for vertical integration right now. So the primes are looking to consolidate their supply chains, not increase their supply chains. So if we can work together collaboratively, provide like services or complementary services as part of that vertically integrated supply chain, less management costs from those primes, less contracts to manage, and we reap the benefits. Win-win to me.
That's also a CEO talk.
I'm sorry.
I know. I just love it. I just love it, and I'm super honored to have spoken to you today. I did learn a lot. Thank you for your time, Heather. You're super successful, and I believe you're going to be way more successful. You have all the attitude, the skills, the technical knowledge, uh, CEO skills. You're doing the right thing. Just keep doing it. And thanks for encouraging people to getting out of their comfort zone. I believe that's you're making the world a better place. Thank you so much for that.
Thank you.
Just for the closing of the show, is there a personal advice or experience you would like to share to the new generation of heat treaters that you have learned in your career that you wish someone would have told you before you started? I don't know, maybe as a CEO or I don't know, you were a VP before. What would you tell this young entrepreneur or young metallurgical engineer that wants to make a living out of heat treating?
I would say get it involved as early as possible. So there's the lure straight out of college to go and work for a very large company. Don't overlook the opportunities provided by a small company. They don't have the names like Aerojet Rocketdyne or Boeing or Raytheon, Lockheed, but in a small company, you will get exposed to so much more. You won't be a cog in a wheel. You are responsible and exposed to the entire operation. So if I was a new person, I would look for an extremely successful small business, not necessarily family owned, but a small business that you can get involved in during one of their active growth phases. Somebody that knows where they're going, has a great mission that you buy into, and then hang out there and try to work your way around and get exposed to as many things as possible so that you aren't thrown in a room just looking at heat treat charts for the rest of your life. For one process, get that exposure. You will be 10 times more valuable because of it.
That's a very deep advice. Thanks for sharing that. So, Heather, love to have you on the show. Heather from Thermalback, all the way from California. I would like to remind the audience we're on YouTube, Spotify, LinkedIn, right? Can you do me a favor here? Go like this. You can subscribe. Please subscribe to the show, hit like, and we'll see you next week. This was Heather Falcone from Thermalback. Thank you, Heather, for this amazing episode.
Thank you. Take care.